Solutions, acids, and bases. Solutions, solubility, and concentration. What does a gallon of milk, a gallon of paint, the air you breathe, and silver jewelry all have in common? The answer is they are all solutions. Many times when people think of solutions, they think it can only be liquids, but in fact, a solution is a mixture that has the same composition, color, density, and sometimes even taste throughout. Solutions can be made out of liquid or gas, just like the air you breathe, and even solid like jewelry. So let's make a solution of lemonade. Well, first you need to add lemon juice to the water and then you stir it up, and then you want to make it sweet, so you add sugar. When you stir the lemon juice and the sugar, they spread evenly throughout the water. Eventually, you won't see sugar crystals anymore because they broke up into tiny sugar molecules and they mixed evenly among the water molecules. Now, if you were asked how to describe this solution of lemonade, well, you need to start describing which substance dissolved in the other. Well, the substance being dissolved is the solute, like the sugar. The substance doing the dissolving is the solvent, and this is the water. Generally, when a solid dissolves in a liquid, the solid is the solute and the liquid is the solvent. So let's say you made a glass of salt water. Which is a solute and which is a solvent? Correct. The salt is the solute and water is the solvent. How about when a liquid dissolves in another liquid? Well, the substance present in the larger amount is usually the solvent, like our lemon juice and water. Again, here water was the solvent and lemon juice was the solute. We also said solutions can be solids or gas, just like the air we breathe. Now, the air we breathe is actually a solution of 78% nitrogen, 21% oxygen, and small traces of other gases such as carbon dioxide, hydrogen, and argon. Now, the solid, like the metal jewelry, then if we're talking about sterling silver perhaps, then sterling silver contains about 92.5% silver and 7.5% copper. Brass is also a solution of copper and zinc metals. When solid solutions are created, these are known as alloys, and they are made by melting the metal solute and solvent together. So how do substances dissolve? Like if we were to add a sugar cube in a glass of water, for example. Well, first we need to remember that water is polar molecules, and this means that they have one end that is positive, which is the hydrogen, and one end that's negative, and that's the oxygen. Now, first, the water molecules are going to cluster around sugar molecules, and the negative ends are going to attract the positive ends of sugar. The water molecules are going to start pulling the sugar molecules into the solution, eventually mixing the sugar molecules evenly throughout the water. This process will repeat as layer after layer of sugar molecules moves away from the solid sugar cube until all the sugar molecules of that sugar cube are evenly spread out. Now, depending on the solute that forms a solution with a solvent, they will form that solution at a particular rate. Sometimes it's very fast, and sometimes it could take a very long time. So, for example, if I were to just drop a sugar cube in a glass of water, do you think it will dissolve instantly? Well, no, it's going to take a very long time for that sugar cube to dissolve. So sometimes there are several things you can do to speed up the rate of dissolving. These include stirring, reducing the crystal size, and increasing the temperature. Now, if you were to drop a sugar cube into a glass of water and start stirring, then what you are doing is bringing more water in contact with more sugar molecules, and that water will attract the particles of the sugar molecules, causing them to dissolve faster. You can also speed up the dissolving process by crushing that sugar cube into powder. If you poured that powder directly into the water, now water is touching an increased amount of surface area. And because dissolving takes place at the surface of a solid, then that's going to increase that surface area and allow more water to come in contact with more sugar molecules. Again, the speed of the dissolving process increases. And then finally, by increasing the temperature of the water, we know that this is going to speed up water molecules, causing them to crash into each other. And these moving water molecules are going to bump into the sugar molecules faster, breaking them loose, and then allowing them to dissolve faster. Now, if we go back to our example of making lemonade and we're adding sugar to it because we like it sweet, we're going to stir and stir, and we're going to keep doing this to allow the sugar to dissolve. However, if we keep adding sugar and keep stirring, there is going to come a point where we're going to notice that the sugar is not dissolving in the water anymore. You're going to see this because sugar granules are going to start maybe floating to the bottom of the glass. No matter how much we stir, they are not going to dissolve. So what we are seeing now is that there is a point at which sugar is soluble in water. And what this means is the solubility of something is the maximum amount of solute, like the sugar, that can be dissolved in a given amount of solvent, such as the water, at a given temperature. Now, when measuring solutions, we also look at the concentration of that solution. Now, let's say we're making chocolate milk, for example. We both add 2 cups of milk to our glass. However, I'm going to add 10 teaspoons of chocolate syrup to my milk, and you are going to add only 2 teaspoons of chocolate syrup to your milk. We stir them up at the same amount of time, we have the same temperature of milk, and we do this until all the chocolate is mixed in, and then we take a sip. Will our chocolate milks taste the same? Well, no. I think mine is going to taste super chocolatey. Do you think yours is as well? Probably not. And this is because my chocolate milk is much more concentrated because it has much more chocolate flavor than yours. Yours is diluted and you aren't tasting the chocolatey taste as much. So a concentrated solution is one in which a large amount of solute is dissolved in the solvent. Compare this to a dilute solution. This is one that has a small amount of solute in the solvent. So how much solute can actually dissolve in a given amount of solvent? Well, that depends on a couple factors, which includes the solubility of the solute, temperature, and pressure. This starts getting tricky, and the best way that I can explain it is explaining the process of making rock candy. Now, rock candy is just solid sugar crystals that have formed on a stick. And to begin making these, you need to start dissolving sugar in water, just like we did before. We're going to stir it up and stir. But once we reach that point where no more sugar can dissolve, well, this is a saturated solution, okay? And so a saturated solution contains all the solute that it can hold at this temperature. But if I were to look, this is not rock candy. So in order to get rock candy, we need to keep going. And we need to get more sugar dissolved. So how we can do that is we increase the temperature of the water. If I increase the temperature of the water, then I'm making it unsaturated, meaning that I can dissolve more solute now in the solvent. So by taking that one saturated solution where no more sugar was dissolving, and by turning up the heat on my water and increasing that temperature, now I'm making my solution unsaturated again, and I can start adding more sugar and dissolve more sugar into the water. So now what happens if I take that super sugar water that I've dissolved so much sugar in and I turn off the burner? Well, if I place a stick in it and let it cool, sugar crystals are going to start growing on that stick. And this is because part of our solute, the sugar, is starting to come back out of the solution. So why is this happening? Well, since the temperature lowered again, now that solvent can't hold as much of the solute, meaning that that colder or that cooler water can't hold as much of the sugar that we put in before. So before it cooled and that water was holding a lot of sugar, it was called a supersaturated solution. A supersaturated solution is one that contains more solute than a saturated solution at the same temperature. Supersaturated solutions are very unstable, which is helpful actually when making rock candy, because when I put a stick in the solution and it starts to cool, then those crystals are going to start growing immediately on that stick, and I get delicious rock candy. All right, this is a great place to stop, and it's time for you to show what you know.